Welcome to the 820. The 820, I named it this and decided to keep all my tracks to 8 minutes and 20 seconds because I'm interested in light and photonics. This week, we're not going to do light and photonics. We're going to discuss binary arithmetic, but flashing lights on front panels of computers and sort of a reason for octal and hexadecimal binary notation. This is because my pin diodes just arrived this week, so I don't have a little benchtop video I wanted to do, and that's going to be hopefully next week. In my search, I came across this, so I've had to share it. There's a website starring the computer, and it turns out this actual real live computer with lots of blinking lights is from a 1950s radar control, like NORAD computer system, and it's in all this panel is in movie after movie after television series after television series. It's even in Austin Powers from this IBM computer panel. So these lights in many movies, where you're trying to find the computer's flashing lights, it's actually the same computer panel or pieces of it in movie after movie, and I just had to share this this website. The front panel lights are important in the history of why we have octal and hexadecimal. You notice these switches are in groups of 3. That's significant. In fact, this computer, the switches are in groups of 4, and groups of 3 is octal and groups of 4. So one of the questions I ask myself is, what happened to the flashing lights on computers compared to the Hollywood computers? But here we have flashing lights, and this computer is decades old, and it ran at maybe 8 megahertz, 3 megahertz. So you can see the lights flashing here. Today's computer is running at 1 to 4 to 6 gigahertz. That's less than a nanosecond. So the light can't even travel a foot in that time. So you're not going to see the lights blink because your eyes can't detect that fast. Even here, the lights on the right are on all the time, but they may be flashing. You just can't see it. But when I got this particular computer, I wanted to actually make the lights flash on the upper left where all the lights are lit up there on the upper left. So I actually wrote a program that would make those lights flash. There's actually a couple of jokes about this from Airplane.
What have you found?
All I found is that these red lights keep moving back and forth. Aside from that, this thing seems to have no other function whatsoever, sir.
Well, that's impossible. It must have some sort of function. I mean, why would the government put all that money into a thing with red lights that keep going back and forth? Doesn't make any sense. Keep working on it.
Sir, these lights keep blinking out of sequence, sir.
I see.
What should we do about it, sir?
Get them to blink in sequence.
And with that, I'll start my discussion. So if you have 1 bit, you can have a 0 or a 1. So you can have 2 things, nothing and something, 0 and 1. Pretty straightforward. And in our case, a light would be a 1 and no light would be 0 maybe. 2 bits, well, you got one that can be 0, 1, and these are all the possible combinations. So you can have 0, 1, 2, 3. So you can have 4 things, and 0 is a thing. One of the most common problems in software is sometimes 0 is nothing and sometimes 0 is something, and it creates a common off by 1 error. 3 bits, here we have 3 bits. This is also octal. And so when you have groupings of 3 switches, they would write a notation 0 through 7 to represent the switch settings. And it's easier to write the number 7 than to write 1, 1, 1. So that's where octal comes from. It's just easier to write 3 bits is an octal value. 4 bits is hexadecimal. And here we have 4 bits. And we can count 16 things, of which 0 is a thing. It's, we could have 0 to 15, or you could have 1 to 16. And sometimes you have off by 1 errors. But again, the hex number is easier. This is a spreadsheet that I created that has hexadecimal, octal, and binary. And I'm going to go over how to make this on a piece of paper, but with spreadsheet first. And I have decimal, octal, hexadecimal, and binary. And the maximum digit for a base 10 is 9, so we can have 0 through 9. And then if we have to have 10, we go to a second column. And for octal, we can have 0 through 7. A number by itself, like if you just saw the number 10, you wouldn't know it's octal. But by putting this big OO character here, that tells us when we read it, of course, it's intuitively obvious to the most casual observer. I had a boss who used to say that. stuff that was not obvious, he would say, oh, that's intuitively obvious to the most casual observer. And therefore, it is most intuitively obvious to the most casual observer that the 00 here means, oh, this column is octal and not decimal. And then here, more common is 0x, 0x, that represents hexadecimal. So what I wanted to show is the max digit is 7, and then when you go to 8, you have 2 digits, and here in hex, you go all the way to F with 1 digit before you go to 2 digits. Octal, 32 is 40. You'll find that multiples of 8 increment the second digit. And then hexadecimal, F, 10 is 16, and 20 is 32. And that pattern kind of continues on and on. The rest of the video is just me trying to do this on paper. And the key is, if you actually get a pad of paper and count binary like this, where the first digit is 0101 and the next digit is 0011, you'll actually get quite good at this. It's engineering paper. My dad used to use this stuff, and my dad was an artist. You don't have to be an engineer to use engineering paper. Let's start at 0, so we can count. Computers think 0 is really important. We're going to have the bit position 0, 1, 2. So for the first digit, we just want to do 0, 1, 0, 1 all the way down. Then we'll do 0, 0, 1, 1. The next row, we're going to be 4 zeros followed by 4 ones. The next one is going to be 8 zeros followed by 8 ones. I can say, yes, this is tedious, but if you do it enough times, it will become second nature. Now this 4 bits makes a nibble, and then the next one is going to be 16 zeros followed by 16 ones. And then this one would be 32 zeros followed by 32 ones. And sometimes you just got to slow down so that you can think like a computer. Then I'm going to have octal here, and that's going to go 0 to 7, hex, hexadecimal, 9. Then we go A, B, C, D, E, F. F is 15. To say with this is just that I find often that I'm doing this and making little powers of 2 tables with maybe hexadecimal to help me look for patterns when I'm debugging a problem. So you actually, if you spend some time just getting a pencil and paper and counting in binary, it can help. It can help you recognize patterns. You'll get some brain muscle memory out of doing this.